Good afternoon, everyone. My name is Gene Epstein, and my company is Global Digital Technology. I would like to welcome you to the video version of our ethylene oxide monitoring in central sterile supply departments and hospitals in service. Over the years, it's been my pleasure to have worked with the central supply departments at Riddle, Paoli, Bryn Mawr, and Lankenau hospitals in supplying ethylene oxide monitors, as well as performing the necessary services to calibrate the instruments and service them to ensure that they are operating correctly. Each year, it's my pleasure to do in-service courses like this at each facility, where we go over most of the material that we'll be talking about in this video, which includes the monitors, why we measure ETO, some safety issues, and emergency response. But we will go into that in a little bit more detail. Once again, each year it's my pleasure to visit each hospital and to do this little course. The first service I did was for Lankenau back in 1992, and that's when Annie Graham and I were so much younger. I now learn that Annie has retired and now has a full-time job visiting with her grandkids, which I might be doing someday myself. Here's why we monitor ethylene oxide and why I do this service each year. You folks use ethylene oxide on an everyday basis in the department that you work in. Ethylene oxide is a sterilant. It is appropriate for porous materials. We'll go over that in a little bit more detail in another slide. And essentially, ethylene oxide, or ETO as it's known, is a colorless gas which is known to be an eye, skin, and respiratory irritant in low concentrations, as well as a carcinogen, a mutagenic, and can have issues with the reproductive system and other hazards to workers. So it can be some pretty scary stuff. The odor of ETO cannot be detected below 700 parts per million, and we'll talk about that parts per million thing in a moment. So it's necessary to use scientific instrumentation to measure ETO. Lots of folks claim they can smell ETO, but unless there is a huge spill, the human nose really cannot detect it. You folks work in a sterile supply department that has an ETO sterilizer and aerator combination. And if you look at the picture to the lower left, that's sort of what they look like. There's one magic box. In previous years, the central supply department consisted of two huge boxes where there was a sterilizer and a separate aerator. As such, once the load was placed into the sterilizer and the load completed, the poor soul that was in charge would need to be the person that would remove that load from one box, that being the sterilizer, and then placing it into the aerator for the aeration cycle. So it was completely manual. It used ethylene oxide cylinders, and if you look at the picture to the lower right, these big, tall, very scary-looking cylinders, and this was the everyday occurrence in a central supply department. The normal process, again, back then, would have been to place the load into the sterilizer, let it complete its cycle, and at the end of that cycle, the operator would crack the door and take a walk for 15 minutes to make sure that any ethylene oxide that might have been attached to the door gaskets or frame had dissipated before they went back into the area to take the load out and then put it into the aerator. As you know, ETO is a sterilant for steam and heat sensitive materials. So things like BP cuffs, ambu bags, flexible scopes are the items that would typically be sterilized in these ETO machines. While ETO alternatives are available, such as peracetic acid and hydrogen peroxide gas plasma, there are still questions as to their effectiveness and suitability for use with all materials. Thus, at this point, ETO sterilization remains the method of choice. So, you guys work with this stuff, and it is of utmost importance that safety in your workplace is maintained. The new sterilizer aerator units are interlocked, and what this simply means is if there is a problem or an issue with the unit, it simply won't operate, unlike the old days. Way back when the technician would have to physically remove the sterilized load and transfer it to the aerator, back then there was a strong possibility the technician could have been exposed to ETO. Today, there is virtually no possibility of exposure. Today's technology actually takes the gas at the end of the cycle and processes it such that only a small amount of carbon dioxide and water vapor are sent outside the hospital into the environment, not ETO. Believe it or not, OSHA regulations have not changed in 35 or so years. But yet, we still need to monitor your work environment and keep you guys safe. The TWA, or time-weighted average, for ETO, or ethylene oxide, is 1 ppm. The excursion limit for ETO is 5 ppm. And as an average over a sample period of 15 minutes, this is sometimes called the STEL, or short-term exposure limit. And we're going to talk about the definition of all of this stuff in a moment. The action level for ETO, or ethylene oxide, is a half of a part per million, calculated as an 8-hour time-weighted average. And this is the level any monitoring system, whether it be ours or any others, would need to be able to detect. So next is, what is this ppm stuff? What is this guy talking about? Each year I go over this at each of the hospitals. ppm, or parts per million, is nothing more than a measurement of concentration, meaning how much ETO is in the work environment. The example that I use to explain this is, imagine 100 pennies on your desk. Spill them out, lay them out, and you know that you've got 100 pennies. If you physically removed 1 penny, you've just taken 1 part in 100, or 1%. Everybody knows that. So now imagine 1,000,000 pennies on your desk and take just 1 penny away. You've just taken 1 part in 1,000,000, which is a very, very small number. So now, if you could imagine the workplace, the central supply department that you're in, and if we put 1,000,000 little cubby holes, little boxes, in that department, and we filled one of those 1,000,000 with ethylene oxide gas, that would be the equivalent of 1 part per million. So again, I think you can imagine this is a very, very small amount. So when we talk about the law, we talk about what someone can be exposed to, and we say the time-weighted average is 1 part per million. What we mean is this. If we work an 8-hour day, and we do the math, and we say there's 60 minutes in an hour, and there's 480 minutes in a day, and then we go to the old method of sterilization, which required the large sterilizer and the transfer to the aerator, where the potential of a worker could be much, much greater for exposure than today. And we opened that sterilizer, and we had an ETO meter right at the door, and for that very first minute, it read 5 parts per million. And then we kept the meter there, and a minute later, the level dropped down to 4. And a minute after that, the level dropped down to 3. A minute later, down to 2. And a minute later, down to 1. And this is typically what would have happened, again, way back then. So if we take 5 plus 4 is 9, plus 3 is 12, plus 2 for that 2-minute period is 14, plus 1 for that last minute is 15. And if we take that number 15 and divide it over the number of minutes in the workday, which is 480 minutes, you would come up with a number that is too low to even measure. That number is the average, or the time-weighted average, that the person would have been exposed to. So again, it is a very, very small number. So in order to measure such a small concentration, we've installed ethylene oxide monitors at each hospital. Each monitor has a meter display showing the concentration of any ETO that might be in the environment. And each monitor has an alarm, so in the event of an ETO leak, the staff would be warned by a blinking light and a really obnoxious sounding buzzer, which annoyed a lot of people over the years. The original monitors that we installed were recently removed and replaced with the latest and the greatest and the newest of the monitors that are available. As I said, the older monitors used a process called electrochemistry, which we're not going to go into, but nevertheless was a very accurate and very reliable analytical method, again, back then, as compared to the newer units, which are all electronic. They are all solid state, way, way more reliable, and way less dependent on maintenance. They have to be calibrated, but the maintenance on them is virtually none. So the slide that you're looking at, you'll see the monitor is comprised of 2 pieces. The black box on the left is what's called the control module, and that's where all the electronics exist. We're looking at the meter, which you'll see the letters ppm, going back to that parts per million, and some switches on it. There's a test button. And if we look to the right, that is the detection module. The silver disc to the left of the blue box is where the sensor is. And the sensor is designed to measure ETO at very, very low levels, and in this case, at the detection level that we talked about prior, at the half part per million. A number of years ago, one of the hospital administrators came to us and said the key concern was many of the central supply departments were located in basements. And what if there was a problem in the basement with anyone else in the facility know what's going on? And at the time, the answer was not really. So we were asked to come up with a solution to this, and the easiest way was to install a telephone dialer. And you'll see this little white module that's right near where the monitors are installed. And they each been programmed with my melodic voice. And so in the event of an alarm situation in any of the central supply departments, the dialer will alert the emergency response team at the hospitals to, number one, as to the condition, and to take the appropriate action that they have been programmed to. Now, with respect to emergency response, in the event of, and let's backtrack a little bit. There are some hospitals in the northeastern area that have two levels of alarm. Normally, one at 1 ppm and one at 5. And anything at the lower level, they expect the staffs to continue to work, let their supervisor know, and the appropriate departments would then come in and remedy the situation. The mainline system, the mainline hospital system, in their emergency response process is any alarm is an alarm. And so in the event that there is an alarm condition, and you will see the blinking light and hear the obnoxious buzzer, we ask all of the staff to leave the department, notify the supervisor, and the supervisor at each of the locations knows the emergency response process. We don't want the staff to be involved with that at all. We ask people to react and not overreact. And a story that I share with each time that I do these presentations is a situation that occurred at one of the New Jersey hospitals that I dealt with many years ago. They had just installed sterilizer aerator combinations, just like you guys have. And there was an emergency call from pediatrics where they needed certain materials sterilized. And the central supply manager panicked. And she put the load in, and she took the ethylene oxide cartridge, put it into its holder, closed the sterilizer door, and it would not start. And once again, she panicked. So she opened the door, couldn't figure out what happened, and then realized that she had put the cartridge in cockeyed, kind of on an angle. And instead of removing it, what she decided to do was to muscle it and see if she could get it to seat. And what ended up happening is she was exposed to ethylene oxide gas. And this is the example that I use about overreacting and panicking. Don't do it. So once again, in the event of an alarm, let your supervisors know, leave the department, and at whatever time it is safe for you to return, you will be so notified. So that in its entirety is the material that I wanted to share with everyone today. You will each be getting a certificate. Actually, your central supply managers each have this, and you'll sign your name to it, and it attests that you attended an ETO in service given by me, and you get a half a CEU for attending. And it has been my pleasure to present this for everyone, and it will certainly be my pleasure to be able to meet everyone in person. Have a good day, and thanks for attending.